Good evening, everyone. So, welcome to my YouTube channel, Math Subgroup. So, today we are going to start a new topic that is called characteristic subgroup. So, it is certain kind of subgroup which satisfy certain property. So, let's see what is this. Characteristic a subgroup H of a group G is said to be characteristic subgroup said to be characteristic subgroup if for every isomorphism of G, if for every isomorphism phi, if every isomorphism phi of G phi of G, we have phi H is mapped to H. Okay. So a subgroup which satisfy this property that you take any isomorphism of G, the image of H under any isomorphism is nothing but H, then H is called characteristic subgroup of G. Okay. Note, if H is characteristic subgroup of G, then we write H C H A R G. This is the notation. If H is characteristic subgroup of G, then we use this notation H C H A R G. This is the meaning. This is the meaning that H is characteristic subgroup of G. Okay. So this is the meaning. Okay. This is the meaning. So we should write G near to CHR. So this is the meaning. Okay. So we are going to prove a result. We are going to prove a result. A characterization of characteristic subgroup. What is that? So I'm writing this. You can say theorem. Let H be a subgroup of a group G, then H is characteristic subgroup of G if and only if phi H, the image of H under phi contained in H for every isomorphism of G. So let's see its proof, how it will work. So one direction is obvious. Now, if H is characteristic subgroup of G, then phi H is equal to H for every isomorphism of G. So, obviously, what is the meaning of this? If phi H is equal to H means, what does it mean? It means phi H is subset of H for every isomorphism of G. Now we will assume convergent statement. Now conversely assume that that phi H contained in H for every isomorphism of G. Okay. Now we know that. So let phi be an isomorphism of G. Okay. Then phi H contained in H. Okay. Let's say it one. Phi H contained in H. Okay. Okay. So this is equation number one. Now, since phi is isomorphism of G implies करता है its inverse, phi inverse is also isomorphism of G. Therefore, we have, therefore phi inverse H contained in H. So what does it mean? It means that we can operate phi both the sides. Okay, what is the meaning of this? Phi compose phi inverse. Phi compose phi inverse is nothing but identity map. So this is identity map. So we have identity map, but identity map takes something to that thing. So it's the image of H under identity map will be nothing but H. Okay. So let's say this equation number 2, sorry. From 1 and 2, we have, from 1 what we have? From 1 we have this one. Okay. And from 2 what we have? This is also containing H. So phi H containing H and H is containing phi H. What does it mean? It means that phi H is H. Okay. Thus, phi H is equal to H for every isomorphism of G. So this implies H is characteristic. H is a characteristic subgroup of G. So this theorem is proved now. Okay. Okay. Now we are going to prove second result, that if H is a characteristic subgroup of G, if H is a characteristic subgroup of a group G, then H is normal subgroup of G. Okay. Let's see its proof, how it will work. Okay. let G belongs to G. Now consider the inner automorphism F G to G defined by phi G F is equal to G inverse F G for all F belongs to G. Okay. Okay. Since H is characteristic subgroup of G, we have F G H will be equal to H. So what is the meaning of this? This is nothing but G inverse HG is equal to H. Okay. So what is the meaning of this? So we have both. So therefore, thus GH G inverse H G is equal to H for every G belongs to G. So this implies H is a normal subgroup of G. Because G inverse HG, what is the characterization of the normal group? This is one of the characterization. If you have for any G belongs to G inverse HG belongs to F, then such group is always a normal subgroup. So this theorem is proved. Okay. So today's lecture up to this. If you have any program related to this, you can comment on my YouTube channel. Like, share, comment, and subscribe my YouTube channel. Thank you very much for today's lecture. Thank you very much.